Today I'm with Matt Wilburn. Matt, how are you, sir?
Good. Thank you for having me.
Well, thanks for coming. What do you do?
I'm an engineer with the U.S. Army Research Laboratory, and I coach the Menchville High School robotics team. We're associated with the first robotics competition, which is an organization developed by Dean Kamen in the late 1980s. FIRST stands for Inspiration and Recognition of Science and Technology, and it's a way to get students interested in science, math, technology, those things that the public school system tends to lose them on, and to get them interested in becoming engineers, programmers, scientists, things like that.
Yeah, and we're at Mad Expo in Hampton, Virginia, and you've got a room. You and your students have a room to yourself with a bunch of robots in it.
Yes.
So they're not just interested; they're excited about this technology.
They're very
this
excited.
This is pretty cool stuff.
Very excited.
Tell me about the projects you're working on.
Okay, well, each year FIRST generates a new game that the students are tasked to design and build a robot. We get 6 weeks after they announce the game and all the rules of the game.
So this is a contest,
It is a competition. And it's played out in arenas all over the world, like basketball arenas, things like the Hampton Coliseum right across the street.
Okay.
They don't actually have a competition there. Our closest one is up in Richmond. We play at the VCU Siegel Center, which is VCU's basketball arena. So big competitions, large size field, 27 by 54 foot field, 120 to 150 pound robots. And so every year the game is different, and you've got 6 weeks to design and build a robot that can play that game the best you can.
What was the game this year?
This year it was called Logo Motion. It was the 20th anniversary for FIRST. So the first logo is a combination of a triangle, a circle, and a square. And so the objective was to put pool tubes shaped in the shape of a triangle, circle, and square in the correct order up onto a rack. And if you could complete a logo, you actually doubled your score for that particular line of tubes.
Okay, and what did you start with? Did you start with the robot, or did you start with just a bunch of pieces of metal?
You start with a bunch of parts. They do give you a kit of parts, which has the electronics that you need, the controllers, the communication equipment, things like that. Has motors and things in it, and a bunch of other parts that you can choose to use or not. And then you have a $3,500 maximum budget that you can use to buy other parts and components to complete your robot.
Okay, and then so you're assembling this kit, adding your own parts to it.
That's
and
correct.
then and then there's some software involved as well.
Definitely software involved. Teams have a number of choices as to how they program their robot. Our team uses LabVIEW from National Instruments.
Yep.
Teams can use C. They can use Java. So there are a number of different options available.
Okay, now I haven't used LabVIEW, but I've seen it. I think it's kind of a drag and drop interface.
Yeah, it's
not
a
a lot
graphical.
of code to write. It's more like assembling things.
Right, it's a graphical interface where each block has a specific responsibility, and you connect it up with individual lines connecting the different blocks to form loops and tasks that it runs.
Okay, and your job is to teach them or to coach them, or what's?
I'm the head coach, so I'm kind of the general team coordinator. I also serve as a mentor on the mechanical team. So this year, the robot that we built, the sub-team that I was mentoring was the team that built the gripper system and the elevator system to hang the tubes. We also have a drivetrain team who's responsible for getting the motion chassis for the robot together. Designed and developed. We have a programming team that programs the system, electronics team that provides all the interconnections, multimedia team that takes photos and videos.
Wow, how big is your whole team?
We had 22 students this year.
Wow. Is the competition still going on?
It's not for this year. Finished for this year. We did great. We actually won a regional event in South Carolina, the Palmetto Regional. We went to a second event in Richmond, Virginia, here locally. Came in second. We did well enough. We were invited to the first World Championship that was in the Edwards Jones Dome, where the Rams play in St. Louis. And we competed there and actually made it to the quarterfinal matches in our division. So did very well.
Can I see this robot?
Sure, we'd love to show it to you.
Let's go look at it right now.
All right, great.
All right, so this is your machine over here?
This is it. This is Genome Gamma, which is our robot for this year.
Genome Gamma,
That's
all right. Was there a Genome Alpha,
There
Beta?
was a Beta, so this is the third robot in our series of genome robots. So it's all based on the triple helix logo with the DNA with the third strand there.
And so you're mentoring people. So the people that actually did the work are folks like these guys right here, right?
Right.
Oops,
High
wait.
school students from Menchville High School in Newport News, Virginia.
And they're controlling the robot right now. Tell me about these controls here.
Well, we have over here, in order to control the robot, we have a joystick that has 3 different angles of rotation. So you have the traditional X and Y, so you can go forward and backwards. But then you can also drive. We have mechanical wheels on our robot, so the angle on the wheels allow you to drive them in different rotations and put sideways torque on the robot that the robot drives along with. So you can actually use the X and Y on this axis to drive the robot sideways.
Do that again.
So it'll go, instead of needing to drive forward and turning, you just do that. And then the controller also has rotation axis that you can spin the robot on a point.
And then here is what we use to pick up the tubes and place them on the rack. We have different levels that coordinate with the levels on the rack. And then we have pickup, which brings it all the way down to the floor so that we can pick up one of the tubes and then close and then lift it up to the level we want, and then we can drop it.
I noticed you're hooked to a laptop here.
Well,
some software running?
In competition, we would have our classmate computer, which is a driver station here. But this is for when we're not connecting to the field. We use this. So our driver station is set up on the laptop, and so we can enable and disable our robot, and then put it into the various conditions that the match would be in, as well as see some of the input and output that the robot reads from the different buttons and everything. And so we run this whenever we're not actually at competition and we're demoing the robot. And so the controls go into the laptop, which relay the signal over to the robot. With our router.
And the robot is actually the one that has the compiled code on it. There's a C-RIO, and it has all the code. We're just using this as a control to radio signals.
Oh, okay. So you don't need the laptop in order to run this thing. They can all be controlled by the robot itself is smart enough to recognize the controls that you're sending it through this panel right here.
Yeah.
Yes.
What software tools do you use to make this?
We use LabVIEW for programming, and that's a very visual-based programming language. People have also been known to use Java and those sorts of languages as well.
What grade are you guys in?
We're rising seniors, both of us are.
What does that mean, rising seniors?
Next year we'll be seniors.
Oh. You'll be seniors next year, and you're going to college next year? The year after that, I mean?
The year after that,
To study engineering of some kind? Is that the idea?
That's
All right.
good.
Sounds like a good head start. Thanks, guys.